Good morning. My name is Chris Rizos. I'm from the University of
Досить відомо, що
Australia.
там щось
I'm also a member of the Bureau of the International Union of Geodesy.
От не знаю.
It's my pleasure to be able to present this keynote address on the topic of what more
Він
can
там працює.
geodesy do for the geoscience.
Родом схоже на італійця.
As you'll see, there are some remarks which are relevant to the relationships between surveyors and other.
Я включив запис, можна щось буде цікаве.
I can summarize the theme of this presentation under these 3 points. The first one is the challenge of maintaining productive interdisciplinary relationships between, say, two scientific disciplines
Може,
or two
сідайте 15 хвилин
professions. The issue of distinguishing between
Можна туди поставити.
there's also, of course, a spectrum of relationships between these two entities, client-provider, that are perhaps indistinguishable, that is, they could be interchanged, or what I guess we'll be working towards is this idea of a win-win partnership where each of the entities brings some complementary skills or abilities to the partnership. I'd like to use geodesy as the example. That's what I know best. Though we can see similarities with survey engineering and geospatial professionals as well. As most of you know, geodesy is today an Earth observation science that contributes to our understanding of the dynamic solid Earth atmosphere. It does it through its scientific methodology, its geodetic services, and its technological toolbox, which we can see here in this slide, and of which I'll be speaking of in a moment. Now, having said that, geodesy should therefore partner with other geosciences to address the critical observational and research challenges of these geodisciplines. We do this by promoting the expert use of geodesy's current capabilities as well as developing new ones. Now, to understand the nature of the geodetic capabilities, one needs to, of course, look at what geodesy is really about.
Форму, так, розмір.
Ну, то, що ми знаємо з цього, правда?
Ну, з
визначенням.
Що, прорвалося? Щось так. Зараз відновлюють може. Determination position.
Визначення. Тобто shape, так?
Так. Ну, тут мало бути ще щось інше зараз, нове може.
Поки нам очі не відкриває.
Щось на інтернеті є, то що забавне.
Definition. So the four-dimensional Earth observation capability of today's geodetic observational and analysis toolkit.
Як це прибрати?
We can rephrase that definition into what I call modern geodesy capabilities. So the first one is the determination of precise three-dimensional points on the surface of the Earth, as well as satellite precise orbit determination with respect to its geodetic reference frame. The second one is the mapping of land, sea, and ice surface geography, the determination of the Earth's time and spatially variable gravity field. And, most importantly these days, is the monitoring of dynamic Earth system phenomena for geoscience applications. And we have here, for example, the solid Earth and ice, deformation, motion, polar motion, Earth rotation, tides, water cycle, mass transport, ground and surface moisture, etc. The atmospheric phenomena in meteorology, total electron content, space weather, circulation, etc. And oceanographic phenomena such as sea level, sea state, tides, circulation, and so on. There are a number of reasons why geodesy has been so successful in transforming itself from a rather esoteric applied science discipline to an important Earth observation science. One of them is the so-called methodology, because many Earth system effects have very faint geometric, rotational, or gravitational signatures. Global and regional cooperation is required. That's a very important part of the geodetic methodology through observation systems, through campaigns, missions, analyses. Furthermore, there's a heavy reliance on space technologies, especially satellite missions such as GNSS, gravity mapping, altimetry, and imaging. Another part of the methodology is extremely important and sets geodesy apart from many other sciences is the central role of geodetic reference frames. The geometric, gravitational, celestial, even the time reference frames, which permit reliable, continuous four-dimensional observation and analysis. Furthermore, there's also another distinguishing feature of the geodetic methodology, and that is the support from a range of geodetic services, from basic observational data to so-called high-level analysis products. Now, in addition, we can also identify traditional geodesies' applied mathematics and statistical skills that allow for very precise measurement modeling, rigorous data analysis estimation techniques, errors and biases calibration, error analysis, result verification, and so on. And these are something that we can see also some surveying sharing. Geodesy also has a very impressive toolkit, and here we have listed the space technologies, space geometric technologies, techniques such as GNSS, VLBI, SLR, and DORIS, satellite ocean and ice mapping through radar and laser altimetry and GNSS reflectometry, satellite topographic mapping using radar, laser, and other Earth observation missions. And finally, of course, there is the suite of gravity mapping missions, plus, of course, ground infrastructure and services, which make up for a very, very capable toolkit. I have mentioned the geodetic services several times, but in fact, they are extremely important, and they really do distinguish geodesy from the other geosciences, as I'll be speaking about shortly. And really, it's the International Association of Geodesy, which is one of the associations of the International Union of Geodesy and Geodesists. And if we look at the range of geodetic services, these provide high-quality products and data to all researchers and to users for a variety of techniques, with a variety of specifications, but all of them are very, very much at geodetic levels of accuracy. So we see the first few, which are related to geometry, and the International GNSS Service is perhaps the best known, but also the International Earth Rotation and Reference Systems Service, which is responsible for the geodetic reference frame. We also have now, more recently, the International Gravity Field Service and its component service. Now, let's look at this organizational chart of the 8 associations that make up the IEGG. You can see there in the red box, the International Association of Geodesy, and we have the other 7 related to the other geosciences. Now, you can see that when we look down into the organization of these associations, geodesy overwhelmingly is represented by services. We have 4 commissions which deal with theoretical topics. The services are the ones that provide those high-level products, data, to support geodetic methodology, to support geodetic activities, to support navigation and surveying as well, and in fact to support other geosciences. And this is clear already in this chart that geodesy is a service-oriented discipline. So let's look at, in a summary fashion, what I call the geodesy view. We see that geodesy has an impressive array of capabilities that contribute to our understanding, as I said, of the solid Earth, atmosphere, and oceans, through measurement of changes that have very faint geometric, rotational, or gravitational signatures. So therefore, geodesy is an important Earth observation science in its own right, with many geodesists now identifying more with geoscience than with geoinformatics or surveying. However, many of the geodetic tools and methods are now commonly used by other geoscientists and engineering professionals. So geodesists can therefore be classed both as tool makers, in the sense that they can help the non-geodesists, as well as geoscientists in their own right. So there are parallels here with surveying and geospatial with respect to the fact that they have innovative technologies, unique skill sets, a disciplined mindset, and a certain relationship with allied professionals such as civil engineers and
Щось тут каже важливо, що ми там типу щось
in a sense, all this leads to geodesists having a sort of a bravado. I wouldn't say hubris. Because geodesists now appreciate they have unique tools that
можна
make
скачати
precise
Ігор Миколаївич.
measurements from a variety of platforms that can be analysed within well-defined observational parameter frameworks to generate a range of high accuracy visualizations. That can be interpreted as spatial and temporal descriptors of Earth system phenomena which contribute to Earth system monitoring, disaster risk reduction, and even the sustainable development. And you can start to see that in the textbooks. Most textbooks don't just deal with geodesy in the classics. Very much emphasize the applications. And these applications, once you read the first few chapters here about the introduction, the backgrounds of the various components, the skill sets, the technologies, you start to see examples of where geodesy is really being a contributor to these studies. And in that sense, is geodesy now just the provider of the technology, or is geodesy also, in a sense, a geoscience that has a legitimate right to study earthquakes, to study water basins, to study ocean circulation, to study
От хай би Мартин це подивився, об'єм.
So geodesy and the geosciences, or in the geosciences, and here I'm going to make a few remarks. So the question is, does geodesy want to largely be a tool maker for the geosciences, or an independent Earth system discipline, or both, or something else? However, does geodesy have the deep know-how, discipline networks, and recognition to contribute to geoscience on its own? That is, do seismologists look at geodesists as being equals, as being having equal contributions to seismic studies, or something else? Because on the other hand, what more could geodesy achieve through appropriate partnerships with other geosciences? Rather than going on its own, rather than just providing toolkits, is there possibly appropriate partnerships where there is a mutual respect between these disciplines? So we start by analysing the long-term goals and challenges of the IEGG associations and those articulated by other forums. I did this last year. I asked each of the associations to give me a couple of PowerPoint slides, setting out what they wanted, what they thought were the real goals and challenges, say, over the coming years. And from that information, I was hoping to sort of identify how there may be some interdisciplinary and cross-disciplinary connections that could be made. So let's look at the IEGG view. Remember, this is now going to try to identify how the different associations could be linked together. So the associations, and there are 8 of them in total in the IEGG, represent most of the geoscience disciplines, essentially in the non-government sector and in the non-operational sector. After each IEGG General Assembly, each new association leadership group develops work programs for the following 4 years. These are manifest as new working groups, new projects, strategic plans, and goals and challenges. The work programs identify key topics for which new knowledge is sought, new collaborative projects are to be developed, new partnerships are to be established, new services proposed and launched, and so on. So clearly they're looking forward. So the following material was provided to me by the 7 IEGG associations. Of course, I excluded the IAFG. And it's really for the current term of 2019 to 2023. I will go relatively quickly through them because I don't think, as you'll see, I don't think they're terribly useful for this exercise. Just to remind you, the 7 associations apart from the IAG, which is there in the red box. You've got the cryospheric sciences, geomagnetism, hydrological sciences, atmospheric, oceanographic, volcanology, and seismology. So this is a very quick tour. I've summarized the inputs from the 7 associations. The first one is the International Association of Cryospheric Sciences. And you can see the major challenges down here. And I've identified some with asterisks where there may be contributions from the others. They're the obvious ones. Basically mapping ice, mapping glaciers, mapping changes in volume, the ice. Then there's the climate parameters, and then there's issues of stability and sea level rise, geodetic focus. Then there's hazards and interactions, and I think you'll see that for almost all of the associations, the issue of understanding complex interactions within the existing framework are listed over and over again, and are therefore, in a sense, what binds the geosciences together. The second association is the International Association of Geomagnetism and Aeronomy, and it's dealing basically with magnetic electrical properties of the Earth and its environment, the Sun, and other planets. And of this, probably perhaps the issue of space weather, studying the ionosphere of the Earth,
Geomagnetic and
there are geodetic tools, geodetic services that contribute to that. The International Association of Meteorological and Atmospheric Sciences, as the name implies, is interested really in weather and climate, and obviously does depend very heavily on Earth observation, space technologies, very, very much data-driven, and is increasingly interested in things like extreme events that are related and connected with disaster. And again, I've identified several of these from the point of view of where geodesy could make a contribution. Again, it's because many of the geodetic technologies, satellite technologies, principally, do, in a sense, sense the atmosphere, sense the troposphere as well as sensing the ionosphere. And in fact, they do provide some very important data for variable weather modeling. The oceanographers, the International Association of the Physical Sciences of the Oceans, they've listed their major challenges, and you can see here monitoring sea level rise, tides, storm surges, currents, circulation, and their spatial and temporal variations. We can see that there are a number of technologies, satellite altimetry, radar altimetry, GNSS, gravity emissions, and so on, that can provide it. And again, this is a discipline that is very much data-driven. It needs data, it needs satellite technologies, it has complex modeling, and in a sense, it's connected also with many operational systems such as the Intergovernmental Oceanographic Commission and many other regional observation systems. So geodesy, in a sense, fits very neatly with this, but for a long time, geodesy has been focused on the land. Of course, oceanography, therefore, looks at the other 70% of the Earth's surface that is water or land. Moving along, we have the volcanologists, and they have their challenges. Monitoring of volcanoes is something that can be done using geodetic technology. So I'll just move along. And finally, the International Association of Seismology and Physics of the Earth's Interior, the seismologists, also have an issue, not only studying tectonic motion, sudden tectonic motion, but also the impacts of that, for example, in tsunami generation. And in a sense, again, geodesy can provide contributions to both of those tasks.
Почему это 32?
А тут в цей придумки ніс.
Я понимаю. Почему ты ДД-32 и ДД-21? Что у меня двое?
Surprisingly, I went rather rapidly through those. I didn't want to spend a lot of time because I have this slide here, and it says, what to make of this? And I found it surprisingly unhelpful. But we can read between the lines. That is, try to get a sense for what the disciplines are doing, what are their principal challenges. Is it data? Is it theory? Is it cooperation? Is it new technologies? And now I want to draw some conclusions, and I've drawn 10 of them regarding the complementarity of geodesy with these other geosciences. And I will also try to drop in a few remarks about surveying professions. The first one is, there is a greater and more creative use of GNSS technology for a range of applications, as I've just mentioned, and not listed them here. Well, geodesists are GNSS experts. We deal with multi-GNSS measurements.
GNSS.
We're responsible for the geodetic analysis software for the national and global GNSS networks and services, etc. And so are surveying and geospatial professionals. Secondly, there's an increased use of satellite gravity mission data and products for example, the hydrological and cryospheric studies, hopefully very soon also in seismology and volcanology. And as we all know, geodesists are the gravity experts, such as their knowledge of and expertise in gravity missions, combining multiple mission data, ground observation data, gravity modeling, gravity services, etc. The third thing to note about how geodesy could partner with the other geosciences is there's an increasing need to mix different sensors in satellite mission data. There's no one sensor, there's no one mission that can really give everything, give all of the data and all of the required accuracies and resolutions. So you really do require careful calibration and validation, procedures and error and bias modeling. And geodesists typically use multiple sensor technologies and analysis for measurement tasks. Furthermore, some of these new, at least to the other geosciences, sensors and missions are in fact geodetic in nature, such as GNSS, altimetry, imaging, and gravity. And really, surveying and geospatial professionals are also concerned with mixing measurement technologies. The fourth one is an increasing emphasis on addressing societal concerns such as disaster risk reduction, including prediction and early warning of a range of natural and anthropogenic hazards, which I've listed some of them there. And geodesy has for many decades sought to use its knowledge for disaster risk reduction. For example, of the rupture studies, sea level rise, land subsidence, and landslides and others. The fifth one is an increasing emphasis on holistic Earth system studies due to the recognition that many of the Earth system phenomena are really highly correlated and coupled. And this requires a multidisciplinary geoscience approach to aid the separation of Earth system signals from noise, the study of four-dimensional process of evolution, and so on. In fact, surveying and geospatial professionals understand the fundamental nature of spatial information for total situational awareness. So we understand that things are coupled, not necessarily perfect knowledge of how that is done, and we really need to be able to look at the big picture. The sixth conclusion I I made was there's an increase in real-time continuous observations of these processes. It should need stable reference frames. You need ground observation networks continuously operating to complement satellite missions. You need sophisticated network and system engineering. You need early warning systems. And geodesists have experience in establishing these frames, as well as complex multi-element observing systems. Remember these services are referring, particularly the IGS, there are literally hundreds of components there, all contributing data analysis, high-level interpretation, and all being done continuously. But then so does surveying and geospatial sometimes permanent systems, such as in the case of deformation monitoring. Others might be project or site-specific. Another one is the increasing attention to so-called four-dimensional issues, such as the challenges of time series and statistical analysis, the issue of gaps in data, datum changes, instrumentation changes, and so on. And geodesy also addresses such issues as rapid changes in
Добре, я зайшов в конкурсний
versus the
відбір,
need
тепер
for
вимоги
continuity
перелік документів, регламент обрання. І все. Не знаю, напевно, різні
varying
структури.
space, science mission capabilities, time varies, as well as the evolution of data analysis methods.
Ні, я розумію, ти просто,
So do surveying.
повинно бути якось так, що людина зайшла швидко знаходить, а там десь воно заховано.
The
Добре.
next one is that we see increasingly the need for improvements in data analysis and visualization.
Анатолій,
And these challenges
от
include
мені
big
треба
data, real-time
друкувати
analysis,
вміти, так? Ну, є положення, вимог перелік документів,
geodesists can
написати
assess
заявчини,
through their backgrounds in
ну і
mathematical
регламент, так?
geodesy,
Регламент обрання.
precise
І
measurement
написано,
modeling,
що тут є форма десь
spatial analysis using
додаток,
geomathematics, and so on, as can surveying and geospatial information.
ну, сильно.
The ninth one? Well, there's an increasing interest in establishing permanent services to address the societal needs, for example, early warning systems for disaster risk reduction, as well as to support individual geoscientists and government agencies. And examples of the IAG services, as well as regional and local services, typically establish close links with operational geodesy and geoinformation agencies. Finally, the last one, modern earth science requires multidisciplinary collaboration, as many of the earth system's processes, as I said, are coupled in complex ways.
Ти ще слухаєш?
So the geodesy skills may be complementary to those
Я
of
б хотів знати,
other
консультуватися з
geoscientists. As teams of geoscientists with different backgrounds can better coordinate experimental or observational activities, interactive government interventions, organizations, and so on.
коротко хотів так знати по кожному.
Well, you all know that surveying and geospatial professions are also team players. Now some concluding remarks. Modern geodesy is an earth exploration science. Geodesy, over the last few decades, has developed a powerful set of tools and methods that are increasingly used by geoscientists. Geodesists are increasingly engaged in geoscientific investigations. And I would contend that Earth system research will advance further with respectful cooperation between geodesy and other geoscience disciplines. Because geodesy can make unique contributions to addressing the modern goals and challenges of geoscience. So I'll conclude my presentation with this question. Can you see the parallels with the situation of surveying and geospatial professionals? Thank you for your attention, and I hope you found this presentation interesting and perhaps even stimulating.
Що він завершив? Що Ігор Миколаївич, кажете, підемо?
So once again, thank you very much.
Хто чим займається?
Так. Ну, сучасно. Сучасно.
Virtual festival. Very inspiring.
Давайте, я звук скручу, хай собі воно. І запис зупиню.
Що це робить?
Аж в 5 майже годині.
Просто з того часу ще переглянути.
Стій. Тут